The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Hello children, welcome back to the class. Hope you all are fine. Today we are going to start the new chapter, Current Electricity. Current electricity. Already in 8th standard you have studied about static electricity, right? In that you have studied how objects can be charged by conduction, induction and through rubbing, isn't it? And what is meant by static electricity? Static means stationary, isn't it? So how can you measure these static charges? It can be measured using a device known as electroscope, isn't it? So now just see this picture. Here you can see a positively charged electroscope, isn't it? It is connected to the earth through a switch. Now what happens when the switch is on? When the switch is on, we can see electrons from the earth move towards the electroscope and neutralize the positive charge. And flow of charge takes place only for a short interval of time. Once the charges get neutralized, what happens? There is no charge for the electroscope. Is it clear? Now look at this picture. Here you can see a bulb is connected to a cell through a switch, isn't it? Now what happens when the switch is on? We can see the bulb glows. Here the bulb glows continuously till we switch off the circuit. So what is the difference between the flow of current in the first and the second situation? In the first situation, that is in the case of an electroscope, the flow of charges takes place for a short interval of time. Whereas in this circuit, the flow of charges takes place continuously until we switch off the circuit. So what is current? We are discussing about current electricity, isn't it? So what is current? Current is the flow of charges. Okay, current is the flow of charges. In conductors, it is through the flow of electrons. Whereas in the case of gases and electrolytes, it is through the movement of ions. Is it clear? And what is the unit of charge? The unit of charge is coulomb. Okay, the unit of charge is coulomb. Now, look at these pictures. In the first picture, we can see the water is flowing through the small pipe, isn't it? So here, the water flows from a higher level to a lower level, isn't it? Whereas in the case of the ball, here the ball is falling downwards and the ball falls from a higher level to a lower level. What about the case of air? You know, air always flows from high pressure area to a low pressure area. And in the case of water, it flows from a higher level to a lower level. So, there should be an energy level difference for any type of flow to occur. എന്തെങ്കിലും ഒരെണ്ണം ഫ്ലോ ചെയ്യണമെന്നുണ്ടെങ്കിൽ എന്തുണ്ടാവണം? എനർജി ലെവലിൽ ഡിഫറൻസ് ഉണ്ടെങ്കിൽ മാത്രമാണ് ആ എനർജി അല്ലെങ്കിൽ എനി ടൈപ്പ് ഓഫ് ഫ്ലോ വിൽ occur. Is it clear? Now look at this picture. Here water is filled in 2 tanks. isn't it? A and B. Now, what happens when the valve is opened? When the valve is opened, we can see the water flows from A to B. And what happens now? Whether the flow of water takes place continuously? The flow of water does not take place continuously. Okay, so it takes place till the water level in both the tanks becomes equal. Or the flow of water stops when the water in both the tanks are at the same level. Is it clear? Now look at the second picture. Here you can see the water level in both the tanks A and B are same. Now what happens when the valve is opened? Whether the water flow here? Here the flow of water will not take place because the water level in both the tanks are equal. That is, there is no change in the energy level. And we have already discussed that for any type of flow to occur, there should be a difference in energy level. And here in both the tanks, the water level is same and there is no difference in energy level. As a result, water will not flow from A to B or from B to A. Now, let us discuss another situation. Here, see to this picture. You can see a bulb is connected to a switch, isn't it? Or in between P and Q, there is a switch and a bulb. Okay, so when the switch is on, what happens? Whether the bulb glows in this situation? The bulb will not glow, isn't it? Why? Here there is no cell or battery. Okay, so in this situation, the bulb will not glow as there is no device to maintain the potential difference. ഇവിടെ ഒരു സെല്ലോ ബാറ്ററി ഉണ്ടായിരുന്നെങ്കിൽ മാത്രമാണ് ആ ബൾബ് കത്തുക അല്ലേ? ഇവിടെ ആ ബൾബ് കത്താനുള്ള ഒരു സോഴ്സ് ഇല്ല, ഒരു പൊട്ടൻഷ്യൽ ഡിഫറൻസ് മെയിൻറ്റെയിൻ ചെയ്യാനുള്ള ഒരു സോഴ്സ് ഇല്ലാത്തത് കൊണ്ട് the bulb will not glow. Okay, so what is the condition for current to flow? For current to flow through a conductor, there should be a potential difference. Okay, once again, for current to flow through a circuit, there should be a potential difference. And current always flows from higher potential to lower potential. See, if a bulb is connected to the positive terminals of the battery, if the both ends of a bulb are connected to a positive terminal of a battery, whether the bulb glows? It will not glow, isn't it? The same way when it is connected, when both the terminals are connected to the negative terminal of the battery, it will not glow. So what we have to do? It should be connected to the positive and negative, isn't it? Only then the current flows. Is it clear? So current flows only when there is a potential difference and it flows from a higher potential area to a lower potential area. And the unit of potential difference is volt. Okay, the unit of potential difference is volt, V. And the device used to measure the potential difference is known as voltmeter. The device used to measure the potential difference is voltmeter, and this voltmeter is represented like this. Voltmeter. And this voltmeter is always connected parallel to a circuit. For example, look at this. This is a bulb and this bulb is connected to a battery through a switch. Okay, അപ്പോൾ ഏതിൻ്റെയാണോ പൊട്ടൻഷ്യൽ ഡിഫറൻസ് നിങ്ങൾക്ക് മെഷർ ചെയ്യേണ്ടത് അതിന് പാരലൽ ആയിട്ട് വേണം കണക്ട് ചെയ്യാൻ. ഫോർ എക്സാമ്പിൾ ഇവിടുത്തെ പൊട്ടൻഷ്യൽ ഡിഫറൻസ് ആണെങ്കിൽ ഇങ്ങനെ വേണം കണക്ട് ചെയ്യാൻ. The positive terminal of the voltmeter should be connected to the positive terminal and the negative of the voltmeter should be connected to the negative terminal. This is known as parallel connection. Okay, so to measure the potential difference, we have to connect the voltmeter parallel to a circuit. Is it clear? Now, when will be the potential difference 1 volt? That is, when 1 joule of work is done to move 1 coulomb of charge from one point to another. ഒരു പോയിന്റിൽ നിന്ന് വേറൊരു പോയിന്റിലോട്ട് 1 കൂളം ചാർജ് മൂവ് ചെയ്യിക്കാൻ നമ്മൾ 1 ജൂൾ ഓഫ് വർക്ക് ചെയ്യുന്നുണ്ട് എങ്കിൽ then we will say the potential difference will be 1 volt. Okay, that is, if 1 joule of work is done to move 1 coulomb of charge from one point to another, then the potential difference will be 1 volt. Is it clear? We have already discussed that for current to flow through a circuit, there should be a potential difference, isn't it? And the ability to maintain the potential difference between the ends is known as electromotive force or EMF. Okay, so what is electromotive force? It is the ability to maintain the potential difference between the ends of a conductor. And there are certain devices that helps to maintain this EMF, or we can discuss about the sources of EMF. Some examples for sources of EMF are cell, battery, generator, etc. Now, look at this picture. Here you can see a water tank is there and there is a pump connected to it, isn't it? So, when the valve is opened, what happens? The water flows from A to B, isn't it? Whether the flow of water stops here? No. The flow of water will not stop as there is a water pump, isn't it? What this pump will do? This pump again takes this water from B to A. കാരണം നേരത്തെ കേസിൽ നമ്മൾ ഡിസ്കസ് ചെയ്തിട്ടുണ്ടായിരുന്നു, ഈ വാൾവ് ഓപ്പൺ ചെയ്ത് കഴിഞ്ഞ് കഴിഞ്ഞാൽ എയുടെ വാട്ടർ ലെവൽ കൂടുതലാണെങ്കിൽ അത് ബിയിലോട്ട് പോയി സെയിം ലെവൽ ആവുന്നത് വരെ ഫ്ലോ ചെയ്യുള്ളൂ. അത് കഴിഞ്ഞാൽ വാട്ടറിൻ്റെ ഫ്ലോ സ്റ്റോപ്പ് ആവും അല്ലേ. പക്ഷേ ഈ സിറ്റുവേഷനിൽ വാട്ടറിൻ്റെ ഫ്ലോ സ്റ്റോപ്പ് ആവുന്നില്ല. കാരണം എന്താ? അവിടെ ഒരു പമ്പ് ഉണ്ട് അല്ലേ. സോ പമ്പ് വാട്ട് ഇറ്റ് വിൽ ഡു? ഇറ്റ് ടേക്സ് ദ വാട്ടർ അഗെയിൻ ഫ്രം ബി ടു എ. So here the flow of water takes place continuously, and which device helps to maintain the flow of water continuously here? The pump. Okay, so the pump here helps to maintain the flow of water continuously. Is it clear? Now let's see the energy conversion taking place in a generator. What is the energy conversion taking place in a generator? Mechanical energy is converted into electrical energy. What about in the case of a cell? In the case of a cell, chemical energy is converted into electrical energy. Okay. Now we will discuss about the connection of cells, or the cells can be connected in two ways: series connection and parallel connection. Okay, look at this figure. Here you can see the cells are connected one after the other. Negative terminal is connected to the positive terminal, and like that it goes on. Such a connection is known as series connection. Just see. Here 3 cells are connected in series. Such a connection is known as series connection. Here this is the negative terminal. Negative terminal is connected to the positive, positive, negative, like that it goes on. Okay, so how will you find out the total EMF of this cell? The total EMF is the sum of the EMF of all the cells. For example, the EMF of one of the cell is 1.5 volt. 1.5 volt ആണെന്ന് ഇരിക്കട്ടെ ഒരെണ്ണത്തിൻ്റെ. ഇവിടെ എത്ര എണ്ണം ഉണ്ട്? 3 എണ്ണം ഉണ്ട് അല്ലേ. അപ്പോൾ what will be the total EMF in this situation? 1.5 plus 1.5 plus 1.5, which is equal to 4.5. So in series connection, the total EMF is the EMF, or it is the sum of the EMF of all the cells. That is the first point. Clear? And what about the current? The current is same for all the cell. The current is same for all the cell. And the internal resistance increases. Resistance, കാരണം ഈ ഒരു പാത്താണ് അല്ലേ. So resistance is more when the cells are connected in series. Okay, see here 3 cells are connected. If more than one cell, it is called a battery. So the internal resistance developed by the battery increases. Okay, and the last point, the current passing or the current developed in the external circuit increases under high voltage. Okay, so once again, if the positive is connected to the negative, if the cells are connected one after the other, such a connection is known as series connection. And what are the peculiarities? The total EMF is the sum of the EMF of all the cells. Second one, the current flowing through each cell is same. Okay, and the third one, the internal resistance developed by the battery increases. And the last point, the current in the external circuit increases under high voltage. So that's all about series connection. Now we will discuss about another connection, that is parallel connection. Look at this picture. Here you can see all the positive terminals are connected together and all the negative terminals are connected together. Such a connection is known as parallel connection. Okay. This is parallel connection. This is the positive terminal and this is the negative terminal, isn't it? So see here, all the positives are connected together and all the negatives are connected together. Such a connection is known as parallel connection. Clear? And suppose if the EMF of all the cells are same, എല്ലാ സെല്ലുകളുടെ EMF സെയിം ആണെങ്കിൽ the total EMF will be the EMF of one of the cell. So in the previous case, in series connection, what was the total EMF? 1.5 plus 1.5 plus 1.5. So it was 4.5, whereas in this case, if all the EMF are same, the total EMF will be the EMF of one of the cell. So here the total EMF will be 1.5 volt itself. Okay, karanam ellathinte 1.5 aanengil, okay, total EMF will be 1.5 itself. Is it clear? And the second point, the total current splits through each cell. നമ്മൾ പറഞ്ഞു നേരത്തെ കേസിൽ current flowing through each cell is same പറഞ്ഞു. ഇവിടെ നമ്മൾ കൊടുക്കുന്ന current ആയിരിക്കില്ല. That current splits into these three branches. Clear? And what about the resistance? The resistance is very less. Okay, the resistance in parallel connection will be less. And more current can be available for a longer time under low voltage. Once again, the last point, more current can be made available for a long time under low voltage. That is the reason why we are using parallel connection in our houses. Is it clear? So, series and parallel connection, I hope you have understood that concept. Can you tell me in which mode are the cells in our TV remote connected? Whether it is in series connection or parallel connection? It is connected in series. Okay, just see to it whether it is in series or parallel. And what about in torch and all? We will be connecting it in series. One positive, but then a negative. So that type of connection is series connection. Next topic is electric current. What is current? Current is the flow of charges. Or we can tell current or intensity of current is the quantity of charge that flows through a conductor in 1 second. Electric current is the quantity of charge that flows through a circuit in 1 second. So we can write current is equal to charge by time. Charge by time. Current is represented by the letter I. So I is equal to Q by T, where Q is the charge and T is the time. And what is the unit of charge? Already we have discussed, isn't it? Unit of charge is coulomb and time is second. So we can tell the unit of current is coulomb per second, or it is known as ampere. Okay, the unit of current is coulomb per second or ampere. And the formula for calculating electric current is I is equal to Q by T. Clear? Suppose 10 coulomb charge flows through a conductor in 5 seconds. How will you calculate current? Once again, if 10 coulomb charge flows through a conductor in 5 seconds, how much will be the current produced there? We know I is equal to Q by T. Here Q is 10, time is 5. So it is 2 ampere. Is it clear? This is how we will calculate current. And the instrument used to measure current is known as ammeter. Okay, ammeter is a device used to measure current and it is denoted like this, ammeter. And this ammeter will be always connected series to a circuit. Look at this figure. Here you can see a bulb is connected to a cell and a switch, and ammeter is also there, isn't it? This is how we are connecting it in series. അതായത് നമ്മൾ one after the other ഒന്നിന് പിറകെ ഒന്നായിട്ട് കണക്ട് ചെയ്യുന്നതാണ് സീരീസ് കണക്ഷൻ എന്ന് പറഞ്ഞു അല്ലേ. When the switch is on, what happens? The current starts flowing through this circuit, the bulb glows and ammeter gives a particular reading. അല്ലേ, സ്വിച്ച് ഓൺ ആക്കുന്ന സമയത്ത് ബൾബ് കത്തും ചെയ്യും. Why the bulb is glowing? Because current is flowing through the circuit and ammeter will give the amount of current. എത്ര കറണ്ട് ആ സർക്യൂട്ടിൽ കൂടെ ഫ്ലോ ചെയ്യുന്നുണ്ടെന്ന് നമുക്ക് അറിയാൻ പറ്റും. Okay, now what happens when one more cell is increased? One more cell is increased here. Is there any change in the glow of the bulb? Yes, intensity of the light increases. അല്ലേ, ഒരു സെല്ലും കൂടെ ഇവിടെ ആഡ് ചെയ്യാണ്. ആഡ് ചെയ്ത് കഴിഞ്ഞപ്പോൾ നമുക്ക് കാണാം the bulb glows more brightly. Is it clear? Now what will happen to the ammeter reading? Will it show the previous reading itself? നേരത്തെ ഇപ്പോൾ 1 ആംപിയർ ആണ് കാണിച്ചെന്നിരിക്കട്ടെ, അതേ ആംപിയർ തന്നെയായിരിക്കും ഇപ്പോഴും കാണിക്കുക? അല്ല, അല്ലേ? Because more amount of current is produced. As a result, the ammeter reading increases. Is it clear? So we can tell as the number of cells increases, intensity of current increases and the bulb glows more brightly, and we can see the ammeter reading also increases. So the ammeter reading gives us the amount of current that flows through the bulb. So what all things we have discussed today? We have discussed about electric current, the formula to find out electric current, and what is the condition for the current to flow through a circuit. And we have concluded that for any type of energy to flow, there should be a difference in energy level. Whereas in the case of current, there should be a potential difference. Okay, so go through the class. If you have any doubts, clarify it with me. See you all in the next class with a new topic.